Now, a virtual quantum network is kind of the higher level version of the emulator framework. So virtual quantum networks are really about emulating the control layer of a network, exposing what we can think of as an application layer for development or user interface for controlling the network. Now, the virtual quantum network would give a user the experience of using a real-world quantum network without having any of the quantum network hardware under the hood. And some examples would be Simulacron or QNetSim. Now, some things that are really challenging with the virtual quantum network is actually incorporating realistic physical modeling within the emulation loop. Since simulating quantum systems is not an easy task, things like using physical modeling to inform this control layer is actually very difficult in practice. And in most cases, it's really just avoided and replaced with very idealized models of entanglement distribution, for example. Now, to build up these virtual quantum networks, the ways that is typically done would be first to have digital twins as this physical layer. When we see sort of examples of quantum key distribution networks being developed right now in sort of the virtual quantum network format, they are often using digital twins deep under the hood to be modeling the QKD devices and the high rates that they operate at. Other frameworks have used things like discrete event simulation and more advanced physical modeling under the hood. But as I said before, these methods can lead to longer latencies, which really do affect the sort of real-time performance of the virtual quantum network. Since emulated devices and networks should be replicating real-time performance, if we are having long latencies in the interactive queries that we're giving to these virtual quantum networks, that will cause problems in that real-time operation.